Let me just talk through this because I know some of you are having a good crack at it and you're sort of getting close, but I just want to push you again in the right direction and how I might approach it, okay? First of all, the first question, how do we feel about the first one? Did we get the first one? What was the first question? So we've got these gaming keyboards that we're selling, and see what's different about this one compared to the other one. Can you see how they don't give you the actual equation? All they give you is revenue and cost. What you can do though is you can still use the same sort of points, right? We know that this is what we call the profit zone. This is what we call the loss zone, where we lose money. And this point here is our break even. William, looking at this one over here, what's the X value of where they cross? So how many keyboards need to be sold to break even? How many? Oh, I think we're over the page. That's the next one. 20, right. So can you see that first mark there? Done. 20 keyboards, right? That's the easy part. Now, something I really need to mention that's very important for you guys. What they recently started doing in HSC exams is they started doing these what we call like unscaffolded questions. So usually questions are like broken up into a lot of parts, right? What they've recently started doing is they've started doing these what they call 5-marker or 4-marker questions, where they don't give you any like steps to do, and they just expect you to, okay, can you do this for me? And so what that means for you guys is unfortunately it makes these questions a lot more difficult. And so hopefully I can start showing you these. Hopefully I can start showing you a lot more of these as we go on, okay? But they do give you a bit of a hint to start though. It says by first forming equations for the cost and the revenue, determine how many keyboards need to be sold to earn a profit of $1,900. So hopefully the question makes sense. Basically what they're asking is, you've got this graph here, and they're saying, okay, here's our situation. How many of these keyboards do I need to sell in order to make $1,900? And you can see why that would be an important question to ask. Let's say you need a certain amount, right? And so that's why they're asking this question. What I saw is that a lot of you guys were sort of doing these questions kind of visually, which is okay, but that's assuming that everything is perfectly to scale, and that also that you can read these graphs with a high degree of accuracy, which is a big assumption sometimes. These graphs should be to some sort of scale because they're on an axis, right? But the issue is reading it so that, because they don't always cross at these at the corners and things like that. So it's always a bit unreliable to do it in that way. The way that I would suggest you do this is, because this is the topic under linear functions, what you should do is you need to be making sure that you're using those concepts, right? For example, this revenue equation over here, let me get rid of some of this stuff. Let's just look at the revenue equation. Hopefully you can work out that equation fairly easily, because that's actually direct variation. It crosses at a vertical intercept of 0, so there's no y-intercept there. And you can actually work out the rise over the run, right? The run is 10 over here. What's the rise? Or be careful though, because I'm looking at because remember you have to think about the rise of the run at that point though, right? 400. So yeah, 400, good. So here, and again, be careful of the scale, because some people are thinking that each of these are 1. Obviously, because it goes up to 10, each of these boxes is actually 2. So just be careful of little things like that. But for example, with the revenue one, the rise of the run, so I can see for the revenue gradient is equal to the rise over the run, or 400 over 10, which is just 40. So your revenue equation is R is equal to 40x, okay? So why is that? Well, basically what they're saying is, it looks like they're selling these keyboards at $40 each, okay? So this is our first equation that we want. But I guess the question is, how do we find the cost equation? And this is where you want to sort of think, what properties do you know about these equations of the lines? For example, Saxon, for the cost equation, do we know the y-intercept of this guy? Yeah? What is it? What's the y-intercept? Where does it cross the y-axis? So this is my cost equation here. And what's its y-intercept over here? Where does it cross the y-axis? 500, right. So that's the first thing, right? Cost equation. y-intercept, okay? And remember, what's the form of your equations? What's y equals to mx plus c over here, right? So I already know that this number here has to be 500. What number am I missing though? I'm missing the gradient, right? I'm missing the gradient. And what methods do we have to find gradient? Well, that's for the intercepts. You're mixing things up. That's okay then. What's the meaning of the gradient again? It's the rise or run, the steepness, right? Yeah, exactly right. It's the steepness. Y-intercepts. Yeah. So, what I'm going to do now is I'm going to say, okay, well, let's find the gradient. The cost gradient is, and it's the rise over the run, right? So what we need to do is we need to go to our cost equation over here, and we need to pick some points which are very clearly on the corners there, because it's a bit unreliable if we're kind of going halfway, right? So I'm focusing on this one over here. I've got one of the points. What's one of the points here, Ethan? One of the points here is 0, 500. We've got one of the points here. For the gradient formula, you need 2 points. And you've got one very clear point here, 0, 500, right? Okay, so that's one of the points that you can use. You can use this point over here, 0, 500. What's another point we could use? Think about how we want to have like whole number coordinates here. I don't want to work with decimals or anything like that. It's a bit unreliable. Nick, yeah. Yeah, so 2800. And how did she get that? Well, each of these here looks like to be 100, right? So that's 600, 700, 800 over here. And that's 20, which Will found earlier. It's 20 is the break-even point. So now you've got the break-even point here. That's 2800. These are your 2 coordinates. And this is where your linear functions knowledge comes in. The gradient, so we usually say m, right? So the gradient is equal to the rise over the run. But when you have 2 coordinates, if you think back to it, you remember that we have what we call x1, y1, and x2, y2. I think this is what Ben was talking about when you talk about the rise over the run. The formula for the gradient, when you have this form over here, well, what's the rise? It's the difference in the y values, right? So the difference in these 2 values here. So the formula that you need is this one over here. Okay? Because the rise is the difference in the y values, how far up you go. So you don't necessarily need the formula. What you can do is you can kind of work out, well, it's 800 take away 500 over how far across do they go? They go across from 0 to 20, or they just go across 20 units, right? So you can take either approach. You can try and use a formulaic approach to do it, or you can do a visual approach. You can just say, okay, what's the rise here? That's 300. What's the run here? Well, it's 20, right? What are we doing? 800 minus 500 over 20 minus 0. So 15, right? So I think some of you actually got 15 as the gradient earlier from like a guess and check or something like that. Oh, Bailey started another way? I'll show me at the end, yeah? Okay. Let me finish this off first. So the cost gradient is 15. So let's put that all together now. C will equal to 15x plus 500. Can you see how we've got these 2 equations now? So that second one was a lot more difficult because it's got a y-intercept there, right? Unfortunately, we still haven't actually answered the question, because what's the question? The question was, determine how many keyboards need to be sold to earn a profit of $1,900. And so, for my business studies students, if we have cost and revenue, how can we work out what profit is going to be? Yeah? I heard it over there. Subtract, right? If revenue is how much money you take in, well, cost is money that you lose, right? That you're paying. So the profit that you earn, the amount that you have left, is just the revenue. Everything you take in, take away the cost of what you have. Does that make sense, right? So the profit is revenue, take away cost. I think I spelled revenue wrong. Revenue, take away cost. Just finishing this off. Caleb, how much profit do we want in this question? We want 1900. So where do I replace profit with? Well, I replace profit here with 1900. What's my revenue? Remember, here's the question, right? The question is, how many do I need to sell? So I don't know what X is, but I want to find it. And I have an equation that represents revenue, right? So what do you think I need to do here at this point? Any thoughts? Because what's the goal? I'm trying to find what x is equal to, right? So I need to introduce x into the equation, right? What did I find the revenue equation was? 40 times x, 40x. So I'm literally going to replace my revenue, R, with 40x. And then the same thing with the cost. I'm going to replace the cost with 15x plus 50. All right, I'm just going to replace those equations that are there. Oh, yes, thanks. Tristan, can you take over? Can you solve this equation for me? What can I do? So I'm going on here. So what can I do here to solve for x? I'm trying to find what x is equal to. Yeah, well, usually when we have equations, they're nice and simple. But what the first thing I would do is, can we remove the brackets here? How could I remove the brackets? Yeah, well, where are the brackets here? There's a negative here. How can we remove those? Yeah, how do you expand them, Luke? Yep. Yep, that's right. Yep. Are there any like terms? Is there anything we can put together here at this point? Yeah, that's right. 15 and 40 we can put together. That's going to be, if we take 40 away from 15, 25.
No, 15 away from 40.
Yep. 40 take away 15 is 25x. I'm getting close. Remember, what are we trying to solve for? I'm trying to solve for x over here. Plus 500, good George. I'm going over the right side because I'm running out of room. And divide by 25. And that's how you get your answer of 96, right? So, here's the takeaway. I've got good news and bad news. The good news is that you guys just did that question, okay? If you're on the phone the whole time, you probably didn't do that question. But if you're looking at this over here, the issue is year 12. That you guys need to be prepared for these types of questions because you will get questions like this in your HSC exam. And in fact, you'll probably get harder questions than this because this is only a 3-mark question. In the HSC exam, they've assured you that you can expect at least a 4 or 5-mark question. And so you can imagine that adds another component into it. So how can you prepare yourself for that? Well, the more of these that you do, the more of these that you see, the more prepared that you will be. And I think that the key thing is breaking down a problem. Like individually, if they ask you all these problems, I know you'd be able to do them because I've seen you do them. But it's the fact that how do I know just what to do from looking at the question? Well, that's where the experience comes in into breaking down this problem then. Any questions about that one? I'll let you copy that down. You're going to go to the next one for me. You're gonna